Here is an example of a drawdown test that has been conducted on a vertical oil well for 24 hours. So the test data, which is bottom hole flowing pressure versus time, is given. Other properties like wellbore radius, porosity of the reservoir, and oil properties are also given. And we're going to find reservoir permeability and skin factor using this data. A copy of this file could be found in the description section. So the first step is to plot bottom hole flowing pressure versus log of time. So we're going to construct a semi-log plot. And in Excel, it's better that we calculate the log of time and then plot the pressure versus that number on a regular axis. So I'm going to add this column, log of time. And obviously we're going to start from time point 0.3 because time 0 does not have a log. So now that I have this data, I'm going to graph it. On a scatter plot. I'm going to make sure X and Y axis, so log of time will be the X axis. Pressure will be the Y-axis. I'm not going to add axis titles and modify the axis range. Alright, the chart now looks better so that we can see if we can find a linear trend here. So obviously not all data points fall on a line, a straight line, but I can see some portion of the plot in the middle have a linear trend. And that follows our expectation. We kind of expect that the very early times we'd have some data that deviate from the straight line, and then for later times we also expect that some of the data points fall out of that straight line. So I'm going to manually draw a straight line to identify those data points that fall on that straight line. So here we go to insert. And we can draw a line. Try to capture as many points as possible. And obviously, I can see that maybe the first 2 points, I should exclude those. And all of these data points, they also do not fall on the straight line. So I'm going to exclude the first 2 points, and then the points after this point. So all of these points in between, those are the data points that are relevant and we will use for the analysis. The rest of them we are gonna exclude. So let me just highlight those points here. Obviously, so these are the points that are relevant. So we don't need the rest of the points. Okay, let me just eliminate those data points that do not belong to this interval. Alright, so I can now get rid of this line. So visually, I can see the straight line. Now I need to find the best fit line. And Excel is going to give it to us. You just need to go to add chart elements and add a linear trend line. So this trend line captures the linear trend, and we can show the equation of this line in which the slope of the line is easily identifiable. Having the slope of this line, we know that we can find the permeability of the reservoir using the given formula. So I'm going to write the slope down in this new cell. Obviously, we're going to work with the absolute value of the slope because it's a drawdown test, so the slope is negative. So the slope, the absolute value of the slope in PSI per cycle is in this case 114.7. So now we can use the formula to find permeability in millidarcy. So permeability is 162.6 times the rate, which is 210, times viscosity, times B over the slope, times formation thickness, which is about 200 millidarcy. We will now calculate the skin factor. Based on the formula, we need to know the initial reservoir pressure and the bottom hole flowing pressure at 1 hour. The initial reservoir pressure is actually the bottom hole flowing pressure at time 0, which is 3,500 psi in this case. Bottom hole flowing pressure at 1 hour, PWF at 1 hour, must be read from the graph. The way we do it is on the x-axis we have log of t. So at 1 hour, log of t is 0, right? And we need to find from this graph what the bottom hole flowing pressure is when log of t is 0. So we do have the formula for this line. The only thing we need to do is to plug 0 for x, and we'll get a y, which is bottom hole flowing pressure at 1 hour. So in this case, if x is 0, y is 2,877 psi, which is our bottom hole flowing pressure at 1 hour. It is very important that you never use the raw data, the data in a tabular format, to find the bottom hole flowing pressure at 1 hour. Because sometimes this 1 hour point might fall out of the range of data that you chose and you decided that's appropriate for the analysis. In that case, picking that data point, picking that pressure for 1 hour will introduce large errors and is not acceptable. So always go to the graph and read the value corresponding to a log of t of 0 as your flowing bottom hole pressure at 1 hour. So PWF at 1 hour is about 2876. And now we can plug everything in the formula for the skin and find its value. Times PI minus PWF at 1 hour over absolute value of the slope
minus log of K over porosity times viscosity times compressibility times RW squared plus 3.23. So our skin value is 0.6.